Hello, statistics. It is Wednesday. We are starting the 3.2 notes today because we had the 3.1 quiz yesterday. Okay, so hopefully you have this document open. We've been hinting at normal curves up until now, and now we actually get to learn what they are. Normal curves are symmetric and bell-shaped. The mean and the standard deviation completely describe them. Meaning, if you know the mean and you know the standard deviation, you know everything about this normal curve. The mean is at the center because it's symmetric, so the mean, the median, and the mode, they're all right there in the middle. And the standard deviation determines the shape of the curve. The wider the standard deviation, the wider and flatter the curve. I'm going to change to something like this. The tighter the smaller the standard deviation, the steeper the curve, something more like that. Okay. Standard deviation goes hand in hand with what's called an inflection point. And an inflection point is a change in curvature. If we were in calculus, we'd be talking about derivatives. But it's a change in curvature. So if you look at the curve here on the right and see kind of where the curve completely straightens out, right in the middle of that is what's called the inflection point. And the exact same thing happens here on the other side. That is where the standard deviation also occurs. So we've got our mean here at 10, and our median, and our mode. And if we draw these down, I'm going to estimate them to be at 11.5 and 8.5. So then this distance from the mean to the inflection point, that distance is the standard deviation. So our standard deviation is going from 10 to 11.5, so standard deviation is 1.5 in this graph. That is always the case. Remember I said if the standard deviation is bigger, the graph is more spread out? That's why the standard deviation happens at this inflection point. All right, let's look at the inflection points over here. And also our mean. So I've got a mean of about 155, and I've got the inflection points at 180 and 130. So that gives me a standard deviation of about 25 units from 155 to 180. Okay, here are 3 examples of what happens with different standard deviations. Notice the longer one is a flatter curve, and the smaller one is a much steeper curve. This part is called the empirical rule. These 3 numbers will be memorized by the time you're ready for the quiz on this section. 68, 95, 99.7 rule. All it means is that if we have a standard curve set up like this, here's your inflection point, so that's one standard deviation, that's the other standard deviation, and then each of these sections is the same width. 68% of the data is going to be within one standard deviation of the mean, either up or down. That's the 68. 95% of the data is going to be within 2 standard deviations, up or down. And then lastly, 99.7% of the data will be within 3 standard deviations of the mean. Now, to be within 2 standard deviations of the mean is considered normal. So if you're outside 2 standard deviations, you are unusual. And that would be with 5% of the population. So anything greater than 2 standard deviations away from the mean is considered unusual. Okay, here, ignore these these decimals. We're going to use 68, 95, 99.7. I want to skip this one and go to the next one. We're going to calculate percentiles without knowing the actual number of people who took the test. All right, so we got Joe, he got a 24, mean is 19, and the standard deviation is 5. So we're going to label this graph. The mean was 19, standard deviation is 5, so that's going to go up by 5s, 29, 34, and down by 5s, 14, 9, 4. Okay, so if Joe got a 24, he's right there. How many people are less than or the same as him? So how many people are in this section of graph? Well, from here over we have 50%, and then this section is actually 34%, because if you remember, those two sections together are 68, so if we divide that by 2 we get 34. So Joe has 50 plus 34. He is at the 84th percentile. All right, now if we take a look at Sydney, she got a 14, so she's down here. How many people are below her? Well, there's 34 people in, oops, I want to change it to a pen. There's 34 people in this section, and there's 50 people, 50% of the people here, so we're actually going to do 50 minus 34, so she is at the 16th percentile. Okay, now, sorry I'm rushing, but I'm out of time. Going back up. This is z-score again, but we're standardizing all scores. Right here where it says x minus mu, that's the same as x minus x bar over s. Mu is mean, and sigma is standard deviation. In some of the assignments we had before, it asked you if the z-score is 0, what is the score? If the z-score is 0, the score is the mean. The standardized mean is 0. If the z-score is 1, what is the standard deviation? And you would subtract the number you got for z-score of 1 and the mean, and you get the standard deviation. Well, the z-score was 1. So the z-score of the mean is 0. The z-score of 1 standard deviation away is 1. So you can standardize all of our data into z-scores, and then the graphs look like this. And this is nice because we can compare all scores. We can do ACT scores, SAT scores, weight, height. And once we standardize them, they all fit in the same pattern, where we have one standard deviation unit and everything is labeled by z-scores or standard deviations away from the mean. Okay, stats. We don't have any homework assignment today. We will continue these notes tomorrow. Come to office hours at 2:15 if you have any questions.